Okay, I did tell you one little lie on the last video, and that was going to be the last one, but it's not. This is definitely the last one on this page. Okay, so the last thing that you need to understand is something called phase difference. Okay, so the phase difference is just how much. If you've got two oscillators going at the same time, by how much is one offset or out of sync or out of phase by the other. Okay, now we'll get into how we do this mathematically later on, but for now, I think it's enough that you understand that you understand it in terms of a cycle. Okay, so if you take the first example here, we say we take one to the right of the equilibrium point, and we're going to release it from here. And then the other one, we're going to start it to the left of the equilibrium point, and we're going to release it there. Okay, so I'll just simulate this and just show you. Okay, so this isn't perfect, but it was a bit better a few minutes ago. So basically, when one was up, I decided to get the other one to come down. Let me see if I can get it a little better now. Nope, it's gotten worse. There. Okay, so what we would say is they are half a cycle out of phase. Half a cycle out of phase. Okay. Yeah, that's a bit better. Okay. So those two oscillators are half a cycle out of phase. And what this means is that, because you have to remember in a mass spring system, one full oscillation goes from here all the way to here and then back again. Okay. So if one of them starts from here and the other one starts from here, that means one of them is half the way ahead of the other, or vice versa, so it will make a difference. Okay. So this is what we would call the phase difference would be half a cycle, and we will use probably a symbol that, a funny looking phi symbol, to denote this phase difference. We'll do that later in the calculations. Okay. We've got another one. We've got two identical mass spring systems that are started in two different ways. What is their phase difference? So one of them is started from here, okay, and the other one seems to be started from the equilibrium line. So, sorry, this one is started from here, measuring from the wrong place by the looks of things, and this one is started from here, from the equilibrium point. So you can imagine that the first one, the top one, has to come all the way up here. By the time this one is here, this one is here. By the time this one gets to here, this one is now back here. And by the time this one gets back to here again, that means this one has moved all the way down to here. So it can be a little bit confusing when you look at it first, but this is actually 1/4 of a phase. And if you think of it in terms of the last one, well, if the last one was a half a phase, they were at opposite ends. Now one of them is starting at the equilibrium point, the other one is still fully displaced. That's going to be 1/4 of a cycle. Okay, so that's your offset or your phase difference there. So this is a very, very similar question in a lot of ways. It's just that when this one is started from maximum stretch, this one is started from here, but it's already on the way back this way. Okay, so hopefully you can kind of get your head around the fact that this one is actually 3/4 of a phase out from it. Okay, the reason I did this is because you have some phase difference questions on that formative sheet that I've asked you to do. And where's it gone? Yeah, this one. Okay. So it's asking about the phase difference. And then the last one, I decided to put in a full phase difference worksheet that I'd like you to have a look through. Okay. Okay. So hopefully you guys will get on okay with that, and make sure you do your work in your own one